This section of Chapter 2 will be a review of acids, bases, pH, and buffers. As mentioned in the first section, water is a polar molecule and is a good solvent, so meaning that substances can dissolve in it. And so when we have water molecules that ionize, they will form into a free hydrogen ion or a H+ proton, and then also into a hydroxide ion. When this happens, there's the same number of hydroxide ions as there are protons in a solution, and so this is what we term as neutral. Neutral solutions have a pH of 7, which means that it's 10 to the negative 7 molar concentration of hydrogen ions. The pH scale runs from a numerical value of 0 to 14. All right, and so when we have a pH of, say, 0, this would be a very strong acid, meaning that there would be a very high concentration of protons or hydrogen ions. A pH of 14 is a very strong base, and so it would have a high concentration of hydroxide ions, okay? And so then we have the inverse relationship then. So if we have a high hydrogen concentration, then this would mean that we have a very low hydroxide concentration, okay? Or if we have a very high hydroxide concentration, we would have a very low hydrogen concentration. So how we determine pH is by this equation here, where pH equals the log of 1 divided by the hydrogen ions, so the concentration of hydrogens in a solution. So water, if it has a hydrogen concentration of 10 to the negative 7, then based on this equation, we get a pH of 7. So a question for you is, if a pH of 6, so pH equals 6, has more hydrogen ions or hydroxide ions? Take a moment to think about that. So this would mean this is going to have more hydrogen ions, okay? So if we had a higher pH, again, that would mean that we would have more of hydroxide ions. Physiologically, we have lots of buffers within our body to help prevent from too acidic or too alkaline of a condition within the body, okay? So the purpose of buffers are to stabilize pH within a solution. And so usually we have two components that make it up so that it can go in either direction. A buffer will have either a weak acid or a weak base. And so it can shift in terms of what the needs are of the body. If we tend to be more alkaline, so if we have more hydroxide ions circulating, say, within the bloodstream, then our buffers will create more of an acidic condition to help neutralize that. And the opposite is also true. So if we have acidic blood, for instance, buffers will come in and create more of a weak base, again, to help neutralize our blood, for example. All right. So when we talk about in the blood, we have the bicarbonate ion and carbonic acid, okay? And so these are going to be what help to neutralize our bloodstream when we have different types of conditions. And so this can be impacted by something like exercise, deprivation of oxygen momentarily, or other variables as well. So here we have the equation where the bicarbonate ion can increase, and so this would be our weak base, or at times when we have a high pH, then we would produce carbonic acid, which would help to bring down our pH. So bicarbonate, again here, will neutralize acids, and carbonic acid will neutralize the bases. And so another example, lactic acid. So when we exercise, this builds up an increase in hydrogen ions. So with lactic acid, what will the buffer be? And so for this one, it would be carbonic acid, the HCO3. So then we'll have an increase in HCO3 minus circulating within the blood to help balance that lactic acid that's built up. Our blood has a very narrow pH range, and so for blood, the pH range is from 7.35 to 7.45. Okay, so if we have blood that has a pH lower than 7.35, this is called acidosis. So acidosis can lead to several different problems. So it can affect the central nervous system. And so this would be like headaches, sleepiness, confusion, loss of consciousness even, and a coma. It can affect the heart, where we can have arrhythmia and an increase in heart rate to try and combat that circulating acid conditions. It can affect our respiratory system, and this is hard to write and talk, respiratory system, and so this could lead to shortness of breath and can lead to coughing. And it also can affect our GI tract, and so this can lead to excess vomiting to help get rid of all the extra hydrogen ions, lead to diarrhea, and then also nausea just because of the acidic buildup. Now, the reverse condition where we have pH of 7 or above 7.45 within our blood is called alkalosis. So alkalosis can be problematic as well if it occurs over a long time, where it too can affect the central nervous system. Similar responses, but confusion typically, and if it's long term, can lead to a coma. Sometimes can affect our skeletal muscle, where we can have hand tremors, excessive muscle twitching, but also we could have numbness and tingling in the face, hands, and feet, or muscle spasms. And then we could also have some GI problems where we have some nausea and vomiting, and the vomiting is to get rid of then the hydroxyl ions that have built up within the blood.